identities, conditional equations, and contradictions. The first thing we're going to talk about is the identity equations. An equation satisfied by every number that is a meaningful replacement for the variable is an identity. Okay, so let's take a look at an example here. If I wanted to solve this equation, 3 times x plus 1 equals 3x plus 3, I would first distribute this 3 to both of those two terms. So we know that we're going to end up with 3 times x, which is 3x, plus 3 times 1, which is 3, and that's going to equal 3x plus 3. From this particular step, you can see that both sides of the equation are equal to each other, which automatically tells you that this is an identity. Now, if we wanted to solve for x, what we would have to do is subtract 3x to both sides. Well, what happens when we do that? Well, we eliminate the x's on the left side of the equation, we eliminate the x's on the right side of the equation, and what we end up with is a statement stating that 3 equals 3. This tells us that this is a true statement. And because this is a true statement, this tells us that this is an identity. What this also tells us is that this has infinitely many solutions. So the way we would say this, or write this out as a solution set, we would say that the set where x such that x is any real number. And why is that? Okay, if we come back to this statement that we talked about here, if we said this is 3x plus 3 equals 3x plus 3. If you pick any value in for x, it's going to be equal to each other. So let's say if I put in x to be 1, 3 times 1 plus 3, does that equal 3 times 1 plus 3? Well, that's true, because 3 times 1 is 3 plus 3, which is 6, and that's going to give us 6 on the other side of the equation. Okay, let's put in another number, 2. 3 times 2 plus 3, does that equal 3 times 2 plus 3? Yes, it does. And we can continue on and on and on. Hence, the reason why we would say that this is infinitely many solutions. So this is considered an identity. Now, let's move on to the next one, which is conditional equations. An equation that is satisfied by some numbers, but not others, is a conditional equation. For example, we have 2x equals 4. Let's solve for x. If we solve for x, we would have to divide both sides by 2. And therefore, we would get x on the left side of the equation. 4 divided by 2 is going to give us 2. So the solution set is 2. Okay? This is conditional because there's only one solution to this particular equation. You may have other solutions or more solutions, but if we check this, right, by saying 2 times 2 equals 4, well, that checks. That means 2 is the only number that is a solution to this equation. So therefore, this is considered a conditional equation. Next, we have a contradiction equation. This is an equation that has no solution, which is a contradiction. Okay, so in this case here, I have this equation where x is equal to x plus 1. Now, if we wanted to continue further, just as we've done in the past, to be able to solve for this equation, we want to solve for x. In order to solve for x, we're going to have to subtract x to both sides. Well, what happens when we subtract x to both sides? Well, on the left side of the equation, x minus x is going to give us 0. On the right side, again, we get 0 plus 1. And therefore, we have 0, which is equal to 1. Now, what does this statement tell us? Well, we know that 0 does not equal 1, and that gives us a false statement. So whenever you get a false statement, that means that you are getting a contradiction. Okay? Ultimately, what you would say here in this case is that there isn't a number that satisfies this equation, no matter what you pick for x. So we would say that there isn't a solution or no solution. Or symbolically, we can draw this as an empty set, which is a circle and a line through it. Or another way is a set with braces that represents a set with nothing in it. Therefore, that is considered a contradiction. So let's go ahead and review this. Identifying types of linear equations. Number 1, if solving a linear equation leads to a true statement, such as 0 equals 0, the equation is an identity. Its solution set is all real numbers. Number 2, if solving a linear equation leads to a single solution, such as x equals 3, the equation is conditional. Its solution set consists of a single element. And number 3, if solving a linear equation leads to a false statement, such as -3 equals 7, then the equation is a contradiction, and its solution set is the empty set, or again, we can write this as a set with nothing in it.